Today we're going to review how to complete the square to obtain a perfect square trinomial. And we're going to be completing the square a little bit in geometry. When we get to it, we'll be writing circle equations, and we're going to have to complete the square to place the circle in center radius form. You saw it last year when you placed a parabola into vertex form. So there's different ways, there are different things we have to do depending on the situation. We're going to start off with just taking a binomial and creating a trinomial. So this is not an equation, we're not trying to balance anything, we're just taking an expression and we're going to change it to create a perfect square trinomial. A perfect square trinomial is a three-termed expression that can be factored into the same binomial squared. So that's what we're going to do. We're going to start with x squared plus 10x. So to do this, I need to create a constant that I add to this expression such that when I factor the trinomial, I end up with the same factor twice. And this is where completing the square comes in. There is a method to do this, a little algorithm. What you're going to do is you're going to take the coefficient in front of the x, in front of the first degree term, and you're going to divide it in half and square it. So we're going to divide first the first degree term, degree coefficient, not the x. We're going to divide it in half, square it, and add it to the expression. That's the process in this case. So I take a 10. 10 divided by 2 is 5. 5 squared is 25. So that's what I'm going to add back in there. So this is x squared plus 10x plus 25 when I'm done. Here's why that works. If I get x squared plus 10x plus 25, I can factor that into an x and an x. Factors of 25 is the square root of 25, which is 5, and it's the sign of the center. That's x plus 5 times x plus 5, which yields x plus 5 squared. That's how I complete the square to start with a binomial and create a trinomial. So let's go through this again. Here I have a binomial x squared minus 8x, and I want to create a perfect square trinomial by adding a constant that will allow us to factor the trinomial into the same binomial twice. So the coefficient in front of the x is 8. Right now I'm going to ignore the subtraction sign. He comes in later. I'm just looking at the 8. So 8 divided by 2 is 4. 4 squared is 16. 16 is what I add up here to complete the square. So my final answer is x squared minus 8x plus 16. We can check that by factoring it again. X and x. The square root of 16 is 4. The center sign is subtraction, so that's what's going to go in here. And that's the same binomial squared, so it works. Things get only slightly more complicated when our coefficient is odd, because we still have to divide that by 2. So 11 divided by 2 is just 11 halves. And then if I want to square that, I'm going to get 121 over 4. Well, we can just keep it like that. That's fine. And he's going to be tacked on here. 121 over 4. So in this case, I have x squared minus 11x plus 121 over 4. He still factors. He factors into x and x, and 11 halves, and 11 halves, and subtraction, because when I add negative 11 halves x plus negative 11 halves x, I get negative 11x. So it still works. That final answer is x squared minus 11x plus 121 over 4. If I have an equation that I want to rewrite, all I have to remember is I have to stay balanced. So if I'm adding something to this side, I have to add it to the other side as well. So if I'm going to rewrite this, 3x squared plus x is equal to 2. This is going to get a little bit ugly. The first thing I have to do is I need to divide away the 3. So I have a coefficient of 1 in front of the x squared. So this is a little bit more complicated just from a fraction standpoint. I have x squared plus 1/3 x, and that's equal to 2/3. But what this demonstrates is you can do this process regardless of what numbers you have. It works with fractions as well as whole numbers. So now I'm going to take the 1/3, and to have the 1/3, let me make my 3 a little bit better. It's the same as multiplying by 1/2. So 1/3 times 1/2 is 1 over 6. And when you square it, you get 1 over 36. So that's what we're going to use. Well, here's what I have to do. I have to add 1 over 36 to this side, which means I also have to add it to that side to stay balanced. So here's what it looks like. X squared plus 1/3 x plus 1 over 36 is equal to 2/3 plus 1 over 36. All right, well, this side is factorable. It factors into x plus 1/6 squared. To add 2/3 and 1 over 36, I need to create a 36 over here in my denominator. So to do that, I would multiply top and bottom by 12. So this is just basic fraction sense here, 12 and 12. So this is really 24 over 36 plus 1 over 36. It's really no big deal. In the end, I get x plus 1/6 squared, and that's equal to 25 over 36. This is actually a way to solve for x. You could keep going. You could take the square root of both sides, add a plus and minus here, and then subtract the 1/6, and it's actually a way to solve for x. But that's a lesson for a different time. For right now, this is all you need to understand, is that if I have an equation and I add to one side, I have to add the same thing to the other side so you stay balanced. The last way of completing, or the last use of completing the square, is placing a second degree function in vertex form. And the only difference here is that we keep everything on the same side of the equation. So, and we have to split some things apart. What we're going to do is create a perfect square trinomial out of the first two terms. And the -5 is just going to be along for the ride until the end. The y is going to stay right where it is. So I have y is equal to, I'm going to put this in parentheses, x squared plus 2x plus blank. That's how I space it out, so I know I have to put something in there. Now, whatever I put in here, since I'm on the same side of the equation, I have to subtract away out here. So this is a minus blank. And then I complete the square for this term. So 2 divided by 2 is 1. 1 squared is 1. So 1 goes in both places. I have the 1 here, and I subtract it away out here, so the value, the meaning of my function doesn't change. And then in the end, vertex form looks like this. Y is equal to you're going to create your perfect square trinomial, so it's x plus 1 quantity squared, and then you combine the minus 5, the negative minus 5 and then another minus 1, and you get minus 6. So the vertex form, here's why it's called the vertex form. This is a parabola, and the vertex, the turning point of the parabola, can be found at negative 1, negative 6. So inside the parentheses, it's the opposite sign. Outside, it's a direct read, and that's the vertex of that parabola. So this is just a basic review of the different ways we can use the different uses for completing the square. We review it now, and it's going to come back when we look at circle equations later on in the year.